Hey everyone and welcome. Today we're going to talk about something huge, but it's a piece of the puzzle that often gets overlooked in the AI world, actually serving large language models. See, it's one thing to train a model, but getting it out there so people can use it and doing it efficiently, that's a whole other ballgame.
So you've done it. You poured all this time and money into getting your model just right. It's powerful, it's brilliant, but then you go to deploy it, and bam, you hit a wall. All of a sudden, you're looking at insane costs, super slow response times, and your super expensive GPUs are just sitting there, not doing much of anything. This is the exact problem that vLLM was created to solve.
So here's the game plan for today. First, we're going to unpack the LLM serving challenge itself. Then, we'll introduce vLLM as the solution. After that, we'll get into the weeds of how it works, look at why it's such a game changer, and then wrap up with how you can actually get it running in production.
Okay, so let's set the stage here. Why is serving an LLM so much trickier than, say, a traditional machine learning model? Well, it turns out the problems are pretty unique, and they get painful fast as you try to scale up.
You know, what's really fascinating here is how all these problems are linked. It starts with this massive memory requirement for what's called the KV cache. And because of that, you're stuck in this constant, frustrating trade-off. Do you make it fast for one user, or do you handle a lot of users at once? If you get that balance wrong, your pricey GPUs aren't being used efficiently, which drives your costs through the roof and makes scaling a total nightmare.
And this is where our hero, vLLM, enters the scene. This isn't just another library you download. It's an engine built from the ground up to attack these exact problems head-on.
So this comes straight out of UC Berkeley's Sky Computing Lab, which is pretty cool. It's an open-source tool that's all about high throughput and being super memory efficient. Really, it's designed to be the perfect bridge between your trained model and a service that's actually ready for the real world.
The key thing to get here is its laser focus. vLLM does not care about training. It is completely obsessed with serving. It delivers incredible throughput, it works with all the models you're probably already using from places like HuggingFace, and, get this, it includes an API server that perfectly mimics OpenAI's. That makes plugging it into your existing apps incredibly easy.
All right, so how does vLLM actually pull all this off? It really does feel like magic, but I promise you it's just some seriously clever engineering. Let's look at the two big ideas that make it all possible.
The first secret weapon is an algorithm called PagedAttention. Honestly, the best way to think about this is like virtual memory, from operating systems, but for your GPU. Instead of demanding one giant, continuous chunk of memory for every single user request, which is super wasteful, PagedAttention breaks that memory up into these small, flexible blocks, or pages.
And this right here just lays it all out. On the left, you've got the old way, these huge, reserved blocks of memory with tons of wasted space in between. That problem is called fragmentation. But on the right, with PagedAttention, memory is given out in these little non-contiguous pages, only as it's needed. The result? Pretty much zero waste. And it lets vLLM cleverly share and reuse memory between different requests. It's brilliant.
The second big idea is something called continuous batching. Okay, imagine a roller coaster that refuses to leave the station until every single seat is full. That's how traditional batching works. It's slow, it's inefficient. vLLM is like a smart roller coaster operator. The second a group of people finishes the ride, it immediately fills those now empty seats with people from the line. It never waits, which means the GPU is always busy, and you eliminate all that expensive idle time.
So that's the tech. But let's move on to the really important part. Why should you care? How do these clever ideas actually translate into real-world wins for your app, for your users, and yeah, for your budget?
Well, here's the headline number. When you put PagedAttention and continuous batching together, you get 2 to 4 times higher throughput than other top-tier serving systems. Just let that sink in. You can handle way more users on the exact same hardware. And that incredible number leads directly to all these real, tangible wins. Your costs go down because your GPUs are actually working for their money. Your users get a much faster, much more responsive experience. Oh, and because memory is managed so well, you can now handle much, much longer context windows, which is a total game changer for things like complex chatbots or summarizing huge documents.
So where does this really shine? It's huge for applications with lots of users at once, like chatbots or those interactive coding copilots where every millisecond of lag counts. It's also fantastic if you're running a platform that serves lots of different customers, because that efficient memory sharing means you can pack more tenants onto the same hardware without anyone noticing a slowdown.
Okay, this all sounds amazing, right? But the next logical question is, how hard is it to actually set up? So let's just walk through what it takes to get vLLM up and running.
And honestly, the team behind this made it unbelievably simple. It's literally a one-line pip install. Then you start the server with another single command, just pointing it to your model. And because of that OpenAI-compatible API we talked about, you can use the client libraries you already have to start sending requests right away. It's that easy to get started.
But, let's be real. No tool is a magic wand. For a real production environment, you still need to follow best practices, like picking the right model size and keeping an eye on your GPU. And it's important to remember, vLLM is only for serving. You still need a different process for training your models. It helps you manage costs, for sure, but it doesn't make them disappear, and you still have to manage your servers and infrastructure.
I think this quote from our source material at Uplatz just sums it all up perfectly. vLLM really is that powerful bridge. It takes a brilliant model out of the research lab and turns it into a tough, scalable, production-ready service that can handle anything the real world throws at it.
So as we wrap this up, the final question is really for you. You've already built the intelligence into your large language model. You've given it all that power. So the only question left is, now that you know about vLLM, are you going to give it the speed it deserves? Thanks for tuning in.